Okay, this is the third revision video for P1 and we're going to look at transferring electrical energy, and there's some calculations in this one which I'll work through with you. So you need to be able to confidently, for common appliances, look at energy transfers and be able to label the types of energy we are transferring with that appliance. So an electrical lamp, for example, the type of energy going in is electrical energy, so that will be on this side, and the type of energy it would give out would be light. That's the useful energy. Obviously it would produce a bit of heat as well, but that would be wasteful energy. In an engine, the type of energy going in is in the petrol, so that's chemical energy. And a car is going to move, so it is being converted into kinetic energy. There are two forms of energy there, so we've got two types of energy transfer examples. Okay. The amount of energy then transferred by an appliance will depend on how long it's on for. So if this lamp was on for a long time, it'd be transferring lots of electrical energy into light, and if that electrical energy is costing us money, it's going to cost us a large amount of money, and it's power. So the bigger the power, the more energy it's going to use. Okay, so the amount of energy depends on how long it's on for and the power of the appliance. Okay, and you need to be able to confidently use this equation here to decide on how much that's going to cost you or how much energy has been transferred. So this is the formula that will appear on your equation sheet. Now there are two sort of versions, if you like, of what this can stand for. So you need to have energy transferred in joules, and we know energy is measured in joules. If we do power in watts times the time in seconds, very important we get the units right. You're not given the units, you need to again remember see how you can remember this, or try and find a way to remember it. Or you can have energy transferred in kilowatt hours, so that's kilowatt hours. If you do power in kilowatts times by hours, it's time in hours. So you can look here, the formula, it makes sense because it's a kilowatt hour because you've multiplied kilowatts and hours together to get that bit over there. So that one is a little bit easier, I think, to remember. We're going to look at some examples as how you use that equation in order to work out how much things are going to cost you. So if we look first of all at this example here, how much energy is transferred by a 2 kilowatt electrical fire that's on for 4 hours? So we want to know how much energy is transferred. Which equation do I need to use? Let's look at what I'm given. 2 kilowatt hours, so that's 2 kilowatts, that's my power in kilowatts, and it's on for 4 hours. So we're looking at the bottom equation, and it will be energy equals the power, so 2 times the time it's on for in hours, which is 4, and we multiply those two together and we get 8. And remember, in physics we need those units, so it's measured in kilowatt hours. Okay, so the energy transferred by that fire is 8 kilowatt hours. So if 1 kilowatt hour costs 5p, what's going to be the cost to this person using this fire? Well, if 1 kilowatt is 5p and we've got 8 kilowatts, it'll be 8 times 5, which is 40, and it's money, so it's pence. All right, so 1 kilowatt hour, or a unit, it's often called, costs 5p. What is the total cost? And it's 40p. Right, let's look at the second question then. This one asks us, what is the power in watts? So it's important, it's asked us for a specific unit here, of a drill that transferred 6 kilowatt hours of energy in 36 minutes. So we've got quite a few different units there. Okay, so we need to have a think about what we're going to use over here. It wants us to find the power in watts, okay? So we could be looking at either of these two. Let's see what else it's given us. It said the energy transferred in 6 kilowatt hours. So we're looking at this one down here, aren't we, with kilowatt hours? But it's got the energy, the time, in 36 minutes, and we need it for an hour. So we're going to have to change some bits about, okay? So if we first of all convert the time into an hour figure for us. So if we have 36 minutes, that will be the same as 0.6 hours. So you divide that number by 60 to find out what it would be, because it's 60 minutes in an hour, 60 seconds in a minute. So divided, that gives us 0.6 hours. We now have that in hours. We'd have this in kilowatt hours, so we can calculate the power in kilowatts. It does want the answer in watts, but we can do that after we finish the equation. The second problem we've got is we want to find the power, and at the minute the equation is written like that. So we need to do a formula triangle. So I always do it with my cross like that, so that's my times. So there, which bits are times together? It's P and T, so that's going to go at the bottom, and my E is going to go at the top. So now I can very easily rearrange my formula. So I want to know the power, which is that one there. So I need to do energy divided by time. So E divided by T. So energy is 6 kilowatt hours, divided by the time, which is 0.6, because we'll convert it into hours. And that's going to give me 10 kilowatts. Okay, if you left the question there, you would definitely get some marks, but it's asked us to convert that into just watts from kilowatts. To get from kilowatts to watts, we need to multiply by 1,000. So 10 times 1,000 would give us 10,000 watts. Okay, so that's the power in watts of the drill that transferred 6 kilowatts hours of energy in 36 minutes. Okay, so that's the answer there for that one. And finally, the last one we're going to have a little look at to work through is if an appliance transfers energy at a rate of 8 kilowatt hours and electricity costs 8p per unit, what is the cost of running it for 3 hours? Okay, so we know we've been told that it's 8 pence for 1 unit or 1 kilowatt hour. Okay, but I've used it for 8 kilowatts hours. So let's first of all find out how much it's costing us just to run it. So 8 times 8 for the kilowatt hours is going to give us 64 pence. Okay, so if I had it on for 1 hour, it's going to cost me 64p, but I haven't. I've got it on. It wants me to find out for 3 hours, so I do 64 times by the 3, and that gives me £1.92 or 192 pence, which I'm going to convert into £1.92. Okay, so that's basically said if an appliance transfers energy at a rate of 8 kilowatt hours and electricity costs 8p per unit or per kilowatt hour, what is the cost of running it for 3 hours? Well, 8p is the same as 1 unit or 1 kilowatt hour. We need 8 kilowatt hours, so it's 8 times 8 is 64p, and it's been on for 3 hours. So we times that by 3 to give us £1.92. Okay, so that's looking at transferring electrical energy using the equation E equals P times T, and we've looked at some examples of how you would use the formula in some sort of exam style questions.